Hello everybody, welcome here to another video by JFB, and in this video we're finally gonna look at the von Neumann architecture and actually see its diagrammatic representation of what it is. So let me just give you a brief flashback if you don't know what the von Neumann architecture is, or if you didn't watch the previous video. So the von Neumann architecture was first published by a man named John von Neumann. I'll just say I'll abbreviate his name. So John von Neumann came up with the idea of a stored program in the year of 1945. So you have a stored program, and he came up with that idea in the year of 1945. What do I mean by the idea of a stored program? Well, before he came up with this idea, a typical computer would be like this. Then you, as a programmer, you always have to come with like a piece of tape, and this piece of tape will have all the instructions and the data which is needed to execute those instructions. So you give this piece of tape to the computer, and the computer will process this tape, executing each instruction one at a time with the data you've given it, and it will give you out another tape as an output. So you have to come in with a tape as an input, then give it to the computer. The computer will carry out the processing and give you another tape as an output. So this became redundant, as if you had to write a huge program, you would need lots and lots of meters of tape actually, not just centimeters, meters of tape, in order for you to execute a very large program. But John von Neumann came up with the idea of a stored program, whereby instead of you coming with tapes, the program would be stored inside the memory of a computer, and all you have to do is to give it data. So you have to give the computer data, and it will use the program which is inside the memory to actually execute instructions and use your data in order to give you an output. If you don't know what a program is, what do I mean when I say program? A program is simply a series of instructions. That's what it is. So an example of an instruction I would say is that get some data from memory location 1, bring it here, add a 1, and give me the result. That's a typical instruction. But don't worry if you don't get what a program is. Just master it as a program is simply a series of instructions being executed by a computer. That's what it is. That's all you have to master. So now let's have a brief look at the components or parts of this von Neumann architecture. And by the way, the architecture is called von Neumann because it was made by a man named John von Neumann in the year 1945. And all it does, it's simply came up with the idea of a stored program. That's all you have to master. Now let's look at the parts of the von Neumann architecture. The von Neumann architecture firstly consists of one of the main and central parts of everything, and that is the control unit, which is simply abbreviated as the CU in typical textbooks. So it's the control unit, and the control unit is responsible for controlling every component within the architecture itself. So it's like the part which is the boss. So it controls everything and it's the boss. So it says that this line of code or this instruction will execute at this time, that instruction will execute there. It controls everything. It is the boss within the von Neumann architecture, the control unit. In some typical examples or some typical textbooks, they will tell you that the control unit consists of something called the program counter and all that, but don't worry, we'll get a look at all that briefly. These are just the main parts which I'm highlighting here. So the first part is the control unit, which controls all the other components within the von Neumann architecture. 2 is the ALU, and the ALU simply stands for Arithmetic Logic Unit. This part is simply explained by its name. Like the control unit was explained by its name when it says it controls everything, this part is also explained by its name. So arithmetic is simply calculations or math. So it's simply math. So this is the part of the CPU which actually executes the math. So if you're adding two numbers like 5 plus 4 to give you a 9, the arithmetic logic unit is the unit which is actually executing those instructions. So it's processing that data, 4 and a 5, then it calculates the sum and gives you a 9. It's actually made up of those logic gates which we looked at in previous videos. If you don't know about the logic gates, please go back in the series and watch all about the logic gates, and you see a typical logic gate which I simulated, which can actually add two numbers. Then 3, we now have the memory unit. So the memory unit is simply the RAM. That's what I can say. So the memory unit is where your program comes and lives in. So this is like the heart of the von Neumann architecture, because this is where the program will be stored, and that's called the memory unit. RAM is simply stands for random access memory. So random access memory, by its name, you can even simply, it's simply memory whereby you can access anything randomly. So you don't need to like follow an order and go one by one, one by one, one by one like that. It's simply whenever you know the location of that thing which you're looking for in memory, you can simply access it. So it's random. This is where the program comes and lives. So the lines of code will actually live on the RAM like that. They will be there, and the computer will get these instructions and actually execute them. So the RAM houses all your program. The program is loaded onto RAM, and the CPU simply executes those instructions. So the RAM is not part of the CPU, which I'm going to explain in last, but these are the main parts of any von Neumann architecture. Let me just clear out the board in order for us to look at the other components of the von Neumann architecture. So moving on from the memory unit, we now have what are called registers. So registers are just fast storage. That's what they are. So you can think of a register as simply the storage component for each single instruction and data. That's what you can think of it. So RAM will host the entire program. All the lines of code will be stored on the RAM. Then a register will come and host every single line of code. And by the way, they're not the same thing. I don't mean like the RAM consists of registers which is storing the program. The RAM hosts the entire program. Then when the computer or the CPU wants to execute an instruction, it will get that instruction, store it on the register, then execute that instruction. So here is the register. The register stores every single instruction and data. That's what it is. And it does that with fast speed as compared to the RAM. You see that in a simulation later. Don't worry so much about it. So just remember, a register stores a single instruction and data. And fifth, we have input and output. So I don't even need to explain much about input and output, because I'm typically guessing that almost everyone knows what this is. So if you don't know what it is, don't worry. You're still learning. You're still a newbie. Continue learning. You get what this is. So input is simply any device. It's simply device that gets data into the computer. It's input. It's getting data into the computer. And a typical example would be the keyboard. The keyboard gets letters, numbers, and all those things into the computer in order for you to actually see them, and all those things to be stored on the computer. Then the output is simply a device which gets data out of the computer. So a typical example, and the best example, is the monitor or your smartphone screen. Your smartphone screen is simply an output device which is showing you all the contents inside the computer. So like you watching this video right now, it's the monitor which is giving you an output. And sixth and finally, we have the CPU. The CPU is simply part of the von Neumann architecture, which acts as the brains of the computer, because this is where all the processing occurs. So this is like the processing part of the entire computer. And the CPU is actually made up of the parts which I'm just from stating, like the registers and all those things is actually what makes up the CPU. If you don't know what CPU stands for, it simply stands for central, and you can get from its name, it's central processing unit. So it's the unit which carries out all the processing aspects of a computer. Now let's look at the diagrammatic representation of the CPU. And by the way, let me not forget, the CPU is not like an individual part. It's actually a composition of the parts which I'm just from stating. And don't worry, you'll get to see what this is shortly. Let me just clear out the board. So in all von Neumann architecture computers, we have what is called the CPU. And I'll draw the CPU as a big box, but don't worry, it's actually a very small part of the computer, but I'll just draw it as a big box. So this is your CPU. This is where all the processing begins, and that's where all your instructions are executed. The CPU is actually just a part of the computer which houses the various parts which I'm just from stating. So don't worry, the CPU is not like some big complex machine inside your computer. No, it's just a simple part of the computer which houses some more simpler parts. So the CPU consists of what we call the control unit. So this is the CU. So the CPU is actually made up of the control unit, and the control unit controls all the other components within the CPU. So it's like the central brain of everything, controlling how things should work. Then another part of the CPU is simply the LLU, or Arithmetic Logic Unit. This is the part which actually carries out all the calculations and all those things. And thirdly and finally, we have the component called registers. So registers are simply fast storage which holds instructions or data. That's what they are. So registers do that, and they do that quickly because they are very fast. So in registers, we have other types of registers within them, like a PC, but don't worry so much about the PC. We have the CIR in here, something like that. Then we also have like an AC, an MDR, MAR, MAR, and I think those are like the basic parts of the registers. So registers is simply part of more registers. So don't worry, the PC is just another type of register, the CIR is just another type of register, and AC is just another register, MDR is also another register, MAR is also another register. I've just combined them all up into one bundle called registers in order for me not to have like all of them spread out and all that things. These are just individual registers within the CPU, and all of them have a function within the CPU. Without them, the CPU cannot actually work. All these components are needed for the CPU to actually work and execute instructions. So this is a typical representation of the CPU. All you need to remember is the CU, LLU, and a bunch of registers which are just combined to be registers. And then finally, we have what we call an input device. So this is input. So this input device may be a keyboard and all those things. So the input device will give data to the CPU. The CPU will process that data, execute some instructions, which are on the memory unit. So everything is separated here. It's not like the CPU has the instructions on its own. No, it has what we call a memory unit. So the instructions are actually on the RAM. So when you give data to the CPU will get the instructions from the RAM and execute those instructions based on the data you have given it. Then it will finally give you an output. That's how it is. So you have a memory unit, input device, output device, and the CPU carrying out all the process. So it's like the communication between an input and processing you to give you an output. That's what the CPU is. So don't worry so much about what happening here. All you have to remember is that RAM hosts the program, then the RAM will give the instructions to the CPU will execute those instructions based on the data I've given it, and it will finally give you an output. So instead of me drawing simply a single arrow here, I also have to give it a double arrow. This arrow represents the CPU asking for an instruction, and this arrow depicts the CPU getting an instructions. That's what it is. So don't get confused. Always remember, the CPU consists of a CU, LLU, and a bunch of registers, nothing else. In the next video, we'll look at all these components one by one, piece by piece, and see how they actually work. But don't worry, I've given you a brief overview of it. As we are following the IGCSE syllabus, don't worry much about it. You just need to know all these things in order to you to become a good programmer. So if you're new here, please leave a like, share, and subscribe. If you're old here, please leave a like, share, and subscribe. Have a good day or a good night wherever you're watching me from. Thank you.